Hello and welcome to another Tech Talk. My name is Stan Voynick and I'm the Chief Technology Officer here at Sierra-Olympia Technology. Today I'll be talking about midwave infrared camera systems and our latest offering, the HexaBlu midwave IR sensor core. The HexaBlu, manufactured by Leonardo DRS, is a hot midwave IR sensor, 1280 by 960 pixels, 6 micron pixel pitch, in a compact package that we build into our product line called the Ventus HD6. The evolution towards small pixel pitches allows the design of high-performance cameras with favorable fields of view while keeping optic sizes manageable. In spite of its small pixel pitch, the HexaBlu has a pretty generous well capacity of about 4.8 million electrons. This gives great sensitivity and dynamic range. These things are really critical for applications such as airborne, land-based, and marine surveillance. Imaging in the midwave IR with cooled sensors has always come with some trade-offs and challenges. The materials used for midwave infrared sensing have to be cooled down to cryogenic temperatures. The goal for these cameras has always been to make them what we call lower swap: size, weight, and power. It's easy to think about the cost of a sensor as being the cost to buy it initially. But really, when we talk about cost of ownership, we're talking about the long term. Not only do you have to figure in the cost to purchase the sensor initially, but with midwave sensors, since they're based on coolers which have moving parts, they do have a finite lifetime. Traditionally, rotary cooler lifetimes have been thought about in thousands of hours, 2,000, 4,000, 6,000 hours. So to really understand the cost of ownership of a sensor system in the long term, you have to think about not only the initial cost of the camera, but the service cost of replacement, change out of a cooler once it reaches its lifetime. So while camera costs for initial acquisition may seem high for midwave systems, the more that we can extend that cooler lifetime, the more that we're bringing down the overall cost of ownership in the long term. In the case of the HexaBlu, we talk about cooler life in tens of thousands of hours, 20,000, 30,000 hours. One of the key things that distinguishes the HexaBlu from previous rotary cooler models is that it features a linear cooler design. Inside this compressor are two pistons horizontally opposed and working opposite each other in a balanced way. One of the things that this does is it balances out the vibration. They've got each of these pistons balanced with each other and moving exactly opposite, so that it really minimizes the vibration created as the pistons move back and forth to compress the working fluid in the cooler. The linear cooler in the HexaBlu has fewer moving parts with lower friction, balanced vibration environment, and the design of this cooler is so robust. The manufacturer has been doing testing on this cooler. Normally when you test coolers like this, you run them for long periods of time and you watch for degradation in the cooler performance. And you can interpret that degradation as the cooler starts to perform less well. You can extrapolate to what the lifetime of the cooler is likely to be as it degrades over time. The manufacturer has been performing testing on HexaBlu coolers in power on, power off, temperature varying environments for 10 years now. And they haven't seen enough degradation in those test articles yet to extrapolate to a cooler lifetime. So we talk about this cooler in terms of 20,000, 30,000 hour lifetimes. The manufacturer also did testing on the Dewar. This is the important part right at the front here. It's a small vacuum chamber where the detector sits behind the window that allows the image to come through from the lens. The integrity of that vacuum is important to the lifetime of the HexaBlu, because if the vacuum degrades, the cooler will no longer be able to keep the detector material at the cold temperature it needs to image. As with the cooler section, the manufacturer has put the Dewar section, this vacuum chamber, under rigorous daily testing, temperature cycles up and down, and after about 10 years of testing, they're not able to extrapolate to an expected end of life for that part of the sensor. This detector is what we would call a hot midwave detector, high operating temperature. Doesn't really mean high temperature, it means warmer than 77 Kelvin that we used to use liquid nitrogen. Because this detector works effectively at 140 Kelvin, warmer than liquid nitrogen temperatures, the cooler doesn't have to work as hard. The result of all these elements is a low swap, high-performance imager with a long lifetime. So this is an amazing little sensor. This is a piece of technology that is beyond anything else we've seen, but it's not quite enough by itself. You need to add an optic to it. You need to house the whole thing, put some electronics around it to get the signals out in a way that's useful for our customers to integrate things. That's our expertise here at Sierra-Olympia. That's what we do. Here at Sierra-Olympia, we've designed the HexaBlu into a product line called the Ventus HD6. This is the flagship of the Ventus HD6 line, the HD6 2.4. Based around the HexaBlu, the Ventus HD6 2.4 features a beautiful 18 to 180 millimeter continuous zoom lens and a set of processing electronics that makes integration into an application easy. The processing available on the Ventus HD6 brings a number of enhancement capabilities to the HexaBlu imagery, and then the resulting product of that is available directly out to video on HDMI or as encoded video over an Ethernet connection. Another offering in the Ventus HD6 product line features a 30 millimeter fixed focal length lens, which is a really nice compact integration. Going the other way in focal length, we've demonstrated a Ventus HD6 product with a 720 millimeter continuous zoom lens, which gives a 0.6 degree field of view at narrow. If you'd like to learn more about the Ventus HD6, contact us here at Sierra-Olympia. We'll be glad to talk to you about your application. I'm Stan Voynick. Thanks for joining me today on this Tech Talk.